Before diving into the differences between a switch and a router, it is essential to understand what a network topology is and why it matters for anyone working in cybersecurity or DevSecOps. A network topology describes the physical or logical arrangement of the devices and links that make up a network. In other words, it answers the question, how are the machines connected to each other, and how does data flow between them? Understanding topology is critical because it directly influences how traffic is managed, where vulnerabilities can appear, and how an attacker might move through a network during a penetration test. There are two dimensions to topology. Physical topology, the actual, real-world layout of cables, hardware, and devices. For example, how many network switches are physically installed in a server room, and how they are cabled together. Logical topology, the way data actually flows through the network, regardless of physical layout. For example, even if all machines are connected to the same switch, the logical path of a packet can differ based on network configuration. For cybersecurity work, the logical topology is often the most important, because it determines which machines can communicate with which and through which intermediate devices. The most common network topologies are bus topology. All devices are connected to a single shared communication line. This is mostly historical and no longer used in modern networks. Star topology. All devices connect to a central device, typically a switch. This is the most common topology in modern local networks, both in homes and enterprises. Ring topology. Devices are connected in a closed loop. Data travels around the ring until it reaches its destination. Rarely used today. Mesh topology. Each device is connected to several others, creating multiple possible paths for data. This is common in wide-area networks and in high-availability architectures. Hybrid topology. A combination of the above. Most real-world enterprise networks are hybrid topologies. In the context of cybersecurity, knowing the topology of a target network is one of the first goals of the reconnaissance phase of a penetration test. Tools such as Nmap are used to map out which devices exist on a network and how they are interconnected. Now let us focus on two fundamental pieces of network equipment, the switch and the router. These two devices are often confused by beginners, but they serve very different purposes and operate at different layers of the OC model. The OC model divides network communication into 7 layers. The most relevant here are Layer 2, called the data link layer, which handles communication between devices on the same local network using hardware addresses, also called MAC addresses, which stands for Media Access Control Addresses. Layer 3, called the network layer, which handles communication between different networks using logical addresses, Internet Protocol addresses, commonly called IP addresses. A switch operates at Layer 2. A router operates at Layer 3. This distinction is the key to understanding their roles. A switch is a device that connects multiple devices within the same local network, often called a local area network or simply a LAN. When a machine sends a packet to another machine on the same local network, the switch reads the destination MAC address in the packet and forwards it only to the correct port, meaning only to the cable connected to the destination machine. This is more efficient than older devices called hubs, which sent data to every device on the network regardless of destination. A concrete example: imagine an office with 10 computers, all connected to a single switch. Computer A wants to send a file to computer B. The switch looks at the destination MAC address, identifies which port computer B is connected to, and sends the data only to that port. Computer C through J receive nothing. This is called unicast forwarding. To remember which MAC address corresponds to which port, the switch builds and maintains a table called a MAC address table, sometimes also called a CA-CAM table, for content addressable memory. It learns addresses dynamically. When a frame arrives on a port, the switch records the source MAC address and associates it with that port. If the destination MAC address is not yet in the table, the switch broadcasts the frame to all ports except the source, and waits for a response to learn the correct port. From a cybersecurity perspective, switches can be targeted by attacks such as MAC flooding, where an attacker sends thousands of fake MAC addresses to fill up the switch's MAC address table. When the table is full, the switch can no longer make intelligent forwarding decisions and may start behaving like a hub, sending all traffic to all ports. This allows an attacker to capture traffic that was not intended for their machine, a technique known as network sniffing. A router, on the other hand, operates at Layer 3. Its role is to connect different networks and forward packets between them based on IP addresses. While a switch keeps devices on the same network talking to each other, a router is what allows a device on one network to communicate with a device on a completely different network, including the Internet. A concrete example: your home network uses IP addresses in the range 192.168.1.0 to 192.168.1.255. When your laptop wants to access a website hosted on a server with an IP address of 93.184.216.34, it realizes that this address is not on its local network. It therefore sends the packet to the router, which is its default gateway. The router examines the destination IP address, consults its routing table, and forwards the packet toward the correct next destination on the path to the internet. A routing table is a list of known network destinations and the corresponding paths, called routes, to reach them. Routers use this table to make forwarding decisions. When no specific route is found, the router may use a default route, which typically points toward the internet. Routers also perform a function called Network Address Translation, or NAT. This is the mechanism that allows all devices on a private local network, using private IP addresses like 192.168.x.x, or 10.xxx, to share a single public IP address when accessing the internet. The router keeps track of which internal device made each outgoing request and routes the responses back to the correct machine. From a cybersecurity perspective, routers are critical devices. Misconfigured routers can expose internal networks, create unintended routes, or allow traffic to bypass security controls. During penetration tests, identifying routers and analyzing their routing tables is a key step in understanding how a network is segmented and whether lateral movement between segments is possible. To summarize the key differences between a switch and a router. A switch connects devices within the same local network. It uses MAC addresses to forward frames. It works at OC Layer 2. A router connects different networks together. It uses IP addresses to forward packets. It works at OC Layer 3. A switch does not know about IP addresses. A router does not need to know about MAC addresses for its core routing function. A switch keeps traffic within a local network. A router enables communication between local networks or between a local network and the internet. It is also worth noting that modern networks often use devices that combine both functions. A home internet box, for example, typically acts as both a switch, for local devices connected via cable or wireless, and a router, to manage traffic going to and from the internet. In enterprise environments, there are also Layer 3 switches, which are switches capable of performing basic routing functions. However, in this course, we consider the classic definitions: a switch for local traffic at Layer 2, and a router for inter-network traffic at Layer 3. Understanding these concepts is directly useful in cybersecurity. During a penetration test, knowing whether you're on a switched network or a routed network determines which attack techniques are applicable. Sniffing traffic on a switched network requires active techniques like ARP spoofing. ARP stands for Address Resolution Protocol, while accessing devices on a different network segment requires understanding the routing configuration. Tools like Wireshark are used to observe and analyze the actual frames and packets traversing the network, and understanding whether you are at Layer 2 or Layer 3 is essential to interpreting what you see. In summary, topology defines how your network is structured. A switch manages local communication using hardware addresses, and a router manages communication between networks using logical addresses. These three concepts are inseparable foundations for any cybersecurity professional.